Okay, folks, we're going to do some more Z-score problems now, but we're going to do ones that are specifically applications to warranties, insurance, and maybe some polls, maybe not. We'll see when we get there, maybe in the next part. But warranty and insurance problems are what we're going to focus on here to start with. And remember, we have to keep our Z-score table handy at all times, and we have to remember how to read all of that. So let's take a look at what a warranty problem is about. Why would warranties have anything to do with Z-scores? By the way, there's a whole field of statistics and mathematics that deals with using these types of things to do stuff about warranties and pensions and insurance, all kinds of things. And that's called actuarial science. And a person that works in that field is called an actuary. So very high paying, like doctor kind of pay sort of stuff. So if you're really good at math and you're really interested, you never know, someday you might be an actuary. Okay, so here's our first example of a warranty problem. A car dealer determines that an average new car will last 65 months without needing major repairs. Okay, so it doesn't mean minor, but without needing major repairs. The standard deviation for this distribution is 4.5 months. Okay, so what guarantee should the dealer give so that fewer than 15% of the cars sold require major warranty work? So they realize that when they give a warranty, they're going to hit a car every once in a while that's going to cost a lot of money for them to fix. That's part and parcel of giving a warranty. But they don't want to do a whole lot of them, so they want a guarantee or a warranty to give to their customers, but they only want to expect to get about 15% of the cars requiring major warranty work. Okay, so here's the way that works. 65 is our mean, of course, and our standard deviation was 4.5 months. So back this way, we'd be at about 60.5, shouldn't it be, right about here? So it looks like this one might be a little bit too far to the left, but we got the right idea anyway. So it says, what guarantee should we do so that we get fewer than 15%? So what we did was, we said the closest Z-score in the table that guarantees less than 15%. So if you look in your Z table, you're looking for point, let's say 1500, and you should get the closest one that's going to guarantee you to be less than that would be a Z-score of negative 1.04. So we won't go back and look at the table. We'll assume that we're okay with that for now, because we've done a fair bit of that already. So using the Z-score formula, we can figure out what X would be. So if we do that and we punch it in, we say X is going to be equal to, or the actual number of months that would guarantee us that we have less than 15% of the population is going to nail us. We punch that in there and we got mu plus Z times sigma, so it becomes 65 minus 1.04 times 4.05. Okay, and that's going to give us, remember, oh, this should be 4.05. Maybe that's why I wasn't getting it quite right. 4.05 months, and that gives us 60.788. So if we want to guarantee that we're going to have less, or at least 15% or less than 15% below us, we're going to have to take 60.788 and round it off to the nearest month. So the nearest month that's below that would be 60 months. If we went with a warranty that was any higher, we're going to start any more months than that, we're going to start getting too many cars. So since 61 months would be over the value of X, a 60-month warranty should be offered. Okay? All right, that's pretty good. Let's look at an insurance problem now. The insurance industry uses standard deviation as a benchmark for risk. Wow, who'd have thought standard deviation had anything to do with insurance? So higher standard deviation in a population means higher risk. Anytime things are not as predictable, that means you've got more risk when you go to put money behind something. So standard deviation measures how close things are to an average, so how predictable they are. That's just another way to look at it. So it says the expected cost of repairs to an average house after a flood in St. John's, the expected cost or the average cost would be $10,000. Okay. So on average, for every house that an insurance company has to fix, it costs them 10 grand in town. So the standard deviation for that is 5,000. That's a lot of variability, but still, insurance stuff has to deal with that. So your standard deviation there is 5,000. So we get a sigma of 5,000. That's for St. John's. Okay. So the expected cost of repairs to a home in Calgary is the same. So mu is the same, but there's a greater variation in the value of homes. So homes are either way more expensive or way cheaper. They're just not as consistent. So the standard deviation is $8,000. So they vary a little more significantly, probably because they're way more expensive in Calgary. Or they just have a lot more variability. So use probability to determine why home insurance is more expensive in Calgary. Okay. So what we're going to do here is we're going to talk about probability. And if we say a certain percentage of data is below a value, then we say the probability that you're above that is equal to that percentage. Okay. So let's say that $20,000 would be, for a company, would be a very expensive claim. So we're going to put that in there just as an example to get our heads around this. Okay, so let's consider a $20,000 repair in St. John's, and then we'll consider one in Calgary, where they have the same mean, but they have different standard deviations. In St. John's, that would give you a Z-score of 2. In Calgary, it would give you a Z-score of 1.25, which means in St. John's, a $20,000 repair would be in the 97th or 98th percentile, we say. So that means 97.72% of the repairs they do would cost less than $20,000, whereas in Calgary, 89.44% would cost less. So that means the likelihood that a claim is more than 20 grand, if you're in St. John's, is only 2.28%, but in Calgary, it's almost 11% that every claim, almost 11% of your claims are going to come in, or about 11% probability that your claim is going to be more than 20 grand. So, got to charge a little more on the premiums in Calgary to cover those expenses. So that's why insurance costs more out there. All right, so for a warranty problem, use the allowable percentage to determine your Z-score, and use the Z-score along with mu and sigma to determine the data value. And for an insurance problem, calculate the Z-score, and then use the Z-score to find the percentage and determine the correct probability from the percentage. Hope that helps.